right, hello, probability and statistics course. We're going to do a new problem today on probability, and I'm going to show my work with a tree diagram instead of using the formula. I think the tree diagram might be nicer, actually. So you should have information on a sheet of paper, but here's kind of the breakdown. We've got marbles. There are 3 red marbles, 1 blue marble, and 5 green marbles. We're going to pick 2 of the marbles without replacement, and if you remember, without replacement means that we do not put the first marble back. Do not put the first marble back. We pick the first marble and we keep it. So our question that we're going to answer is, what is the probability that we get 1 red and 1 green? So I'm going to come back to that question here, but I'm just going to make the tree diagram. We'll talk about the sample space for this because we said today in class Wednesday in class that tree diagrams are nice for coming up with the sample space. And then we'll see if we can calculate that probability. All right, so for my tree diagram, we'll talk about the first marble and the possibilities for that, and then we'll talk about the second marble. One tip I think I've mentioned is if you even have like lined paper, if you turn it so that you have vertical lines, you can kind of use this to help organize your tree diagram and make it a little more neat. But we'll talk about the first marble, we'll talk about the second marble, and then we'll talk about the results, and then we'll talk about the probability. So first marble, I start off here. And first marble could be any one of these colors. I got a little picture up here. I got 3 red, 1 blue, 5 green. If you don't have colors to work with, you might just write R, R, R for the 3 red, B for the blue, G, 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 all those G's. You don't need colors necessarily then. But I go to pick my first marble and I say, just what's possible? Well, I could pick one of these 3 red marbles. I could pick this blue marble, or I could pick one of the 5 green marbles. So if we're just talking about the sample space for just the first marble, the sample space, what's possible is red, blue, green, that's it. Remember, for sample space, we don't need to say, oh, could be red, or it could be red, or it could be red. I go, you already told me red, you don't have to tell me again. So first marble could come out red, could come out blue, or it could come out green. And you don't have to draw, but I like to pretend like I'm starting here and I'm going to follow one of these 3 paths. I see a lot of students that skip the branches here, and that's okay. I like to just pretend we're starting here, and then for my first marble, I'm going to follow one of these 3 paths or one of these 3 branches. Okay. And I'm going to fill in my probabilities as I go. So the probability that the first marble is red, there are 3 red marbles out of, what's our total here? It's out of 9, I believe, right? 3 plus 1 plus 5. That's a total of 9. Let's write that in. So for the first marble to be red, there's 3 red out of 9 total. That could reduce to 1/3 if you want to. I'm not concerned about reducing our fractions right here. It could be red, or it could be blue. The probability that the first marble is blue, there's 1 blue marble out of 9 total. Still out of 9 total. 1 blue out of 9 total, that's your basic probability of getting a blue marble first. And then a green marble, there's 5 out of 9 there. Okay, so I can put those probabilities along the branches. So that probably is good, actually, to write those, to draw the branches so that you can put the probabilities on the branches. All right, now the second marble, this is where we have to think carefully about what's possible for the second marble after the first marble. So if I get red on the first marble and we are going without replacement, so that means we don't put it back. So pretend maybe it's this red marble here, and I go, all right, I pick that red marble. It's not there anymore. Now I go to pick again. Well, I could still get a red marble. There's still 2 left. I could get a blue marble, or I could get a green marble. So from the first marble being red, I'm going to branch off again to 3 possibilities: red, blue, or green. And I'll ask myself, if the first marble was red, I'm not putting it back. What's the probability that the second marble is red? And this is where you might want to help yourself out and either, draw the colors or write the letters for the colors. But yeah, if I pick a red marble and I don't put it back, when I go to pick the second marble, there's only 2 marbles now. So we would have a probability 2 marbles, and there were 9 total, and I took one away. So on the second marble, regardless of the color, I don't know if that makes sense. The total is 9, but then it's going to be 8. So when I pick one of those red marbles, whatever red marble it is, for the second marble, if I want the second marble to be red after the first was red, there's 2 red marbles out of 8 total. If I pick a red marble first, and then I want to say what's the probability the second marble is red after the first marble, or excuse me, second marble is blue after the first marble is red, well, I'm thinking that I picked a red marble first, so I'm still thinking like this. And I go, okay, there's the 8 total, one of them is blue still. I still have 1 blue marble, but our total is down to 8. So probability for a blue marble, this would be 1 out of 8. And then again, if we think about the first marble being red, and we go to pick the second marble and we're thinking about it being green, there's still 5 green marbles out of the 8 total. So this would be 5 out of 8. But what if the first marble was blue instead of being red? So if I pick the first marble, let's see if I can just cover that part up. And now I go to pick the second marble. I say, what's the possibilities for the second marble after the first marble being blue? Well, since we're not putting the first marble back, if the first marble's blue, it's gone. So in that case, off of this branch, I only have 2 possibilities, red or green. And so I can ask myself, what's the probability if the first marble is blue, what's the probability the second marble is red? And again, if you want to help yourself out and pretend, cover it up, whatever you want to do, grab some color cubes. The second marble being red, there's 3 red, there's 8 total. So the probability that the second is red after the first is blue is 3 out of 8. If we pick that blue marble first and don't put it back, the probability for green, there's 5 green out of 8 total. We're almost done with our tree diagram here, but we've got one more possibility to consider. What if the first marble was green? So I pick one of those green marbles and I don't put it back. I could get now red, blue, or green. I'm back to 3 possibilities. So 3 branches coming off of this. Could be red, could be blue, could be green. And we can ask ourselves the probabilities of each of those. If the first marble's green, there's still a total of 8 for the second marble. Regardless, our total for the second marble is 8. But let's see here, 3 red out of 8 total if the first is green. Pick a green first. There's 1 blue out of the 8 total. So the probability that blue is second after green is first is 1 out of 8. And if we pick a green marble first and want to pick a green marble again, we've got 4 green marbles out of the 8 total. Half of those marbles are green. So there's, I would say, pretty much completed tree diagram. I'll write down the results of all these, but we have how many ending points? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 different possible things that could happen between the first marble and the second marble, putting those together as a compound event. So if we look at the results here, if I end here, if this is where I end up, this was the result of red being first and red being second. So maybe I write that as RR, red first, red second. If I end up here, it was red first, blue second, red, blue. If I end up here, red, then green. If I end up here, that's blue, then red. If I end up here, that's blue, then green. Remember, we can't get blue twice because there's only one blue marble and we're not putting it back. That would be 0 if you wanted to include it. You could say, oh, we forgot blue. That would be 0 out of 8, 0%. It's impossible. And in here would be green, then red. Here would be green, then blue. And here would be green and green. Now, this is the sample space right here. When we talk about this compound event of picking 2 marbles and we say what's possible, this is the sample space. I'll do this in black. So if you were asked that question about a compound event to give the sample space, you could be like, I could do a tree diagram. And there's your sample space. Our probabilities now, you can go back to the formula, but all we do to get the probabilities of each of these results is we multiply the probabilities as we travel along the branches. So the probability that both marbles are blue is going to be, both marbles are red. I would follow this. I'd have 3 out of 9 and 2 out of 8. And I would multiply those. So 3 out of 9 multiplied by 2 out of 8, and that's 6 out of 72. We'll change that, we'll come up with our answer here to what's the probability of one being red and one being green. We'll get that in a moment. We're going to get all the individual probabilities first. Probability for red-blue, that's 3 out of 9 and 1 out of 8. Oops, probability. Three out of 9, we said, and 1 out of 8. So that's 3 out of 72. Probability of red-green, 3 out of 9 for red, 5 out of 8 for green. What did we say? 5 out of 8 for green. So that's 15 out of 72. Okay, we got 5 more. Blue-red, that probability, that's going to be this branch, 1 out of 9 and 3 out of 8. Blue-red, 1 out of 9 times 3 out of 8, right? Did I get those numbers correct? Okay, so that's 3 out of 72. Blue-green, 1 out of 9, 5 out of 8. So that's 5 out of 72. Just write that. Green-red, 5/9 times 3/8. Right, get those numbers correct, 5/9 and 3/8, so that's 15 out of 72. Green-blue is going to be 5/9 times 1/8. So that's 5 out of 72. And then green-green is 5 out of 9 and 4 out of 8. Multiply those together. So that's 20 out of 72. Okay, so let's look at the question now. And of course, you can pause this video, but when you're ready, let's think about the question. What's the probability of 1 red, 1 green? So you might think, oh, are we just going to be 1 red, 1 green? Is that just right here? And I would say, well, the notation I'm using here, I'm specifically saying, whoops, as I throw markers at myself. I'm specifically saying that I want this represents the first marble being red and the second being green. But the question makes no mention of the order. So I go, ooh, so that could be red first, green second, or it could be green first, red second. Don't know where that marker went. So we could also be right here. So I go, I want this probability together with this probability. Either one works. I don't care which one's first and second. I just want 1 red and 1 green. So now we can say, where can I write this on the board here? Probability for 1 red and 1 green, I can say that's the probability of red first, green second, or green first, red second. And you might remember this or tells us to add. So the probability of red, green plus the probability of green, red. So they're each the same. That doesn't always happen, by the way. Depends on the situation, but they're each, what do we have? 15 out of 72. And we talked on Wednesday about adding fractions. We said, well, like 15 apples plus 15 apples is 30 apples. 15 out of 72 plus 15 out of 72, that'd be 30. We keep the 72. So that was a lot of work just to get that. If the formula is easier for you and you want to use that probability of A and B formula, do what works for you. But I think this is great organization, helps me with the sample space. We'll do the decimal to the nearest thousandth. So what's 30 divided by 72? 0.4166, so that'll round to 0.417. And then that's 41.7% probability. So there's our final answer. That's the probability that you get 1 red, 1 green in either order.